This lesson is on radical functions. So the most simple radical function is the square root of x. Okay? So you'll see that as f of x equals the square root of x. Now we talked before about inverses. The square root of a number is the inverse or opposite of the square of the number. We know that we undo the square by taking the square root. So this is the inverse of f of x equals x squared. So as we think about what the graph looks like, let's start with our x squared graph, which you can see right here. That's our parabola. And I've drawn my line for y equals x because that helps us. Remember, that's our mirror. Whenever we talk about an inverse, that y equals x is our mirror. So if I took this and mirrored it so that now instead of swooping up here along the y-axis, it's now swooping along the x-axis, that would be the inverse of this function. However, function, f of x means it's a function, not just an equation, not just a graph, and a function has to pass the vertical line test. This function here, or this graph, does not pass the vertical line test, so it's not a function. Okay? So what you'll commonly see when we talk about the function f of x equals square root of x, see what I've done right here? We've taken only the positive values of the square root. Remember, the reason this goes in two parts is because let's say I had the number 9. If x equals 9, the square root of x might be 3, but it might be negative 3. So here I'd have positive 3, let's say, and negative 3. That's why I'd have the top and the bottom. But you'll often see convention says, you know what, let's just look at the positive square root for this portion when we're talking about this as a function. So this is what the graph would look like as a function. Okay, but I wanted you to see where it comes from. What is the origin of the graph moving this way over to the side? So it's really just a reflection of the positive values instead of both positive and negative values. Now, when we talk about the domain and range of this function, again, y equals the square root of x, I'm not allowed in the real number system to take the square root of a negative number. So my domain is restricted. My domain has to be greater than or equal to 0 because if I have a negative number inside that square root sign, then I'm going to have an imaginary answer. And this is the real number system. Okay? The range we just talked about by looking at the graph, technically for y I could get out all real numbers because if I put a number in here and I take the square root, every square root has a positive and a negative that it could have been. But when we talk about the range of the function, I want you to think about when we only took the positive half, in which case y is greater than or equal to 0, just like x is, because that's only up in that positive quadrant. Okay? So I don't mean for that to be confusing, but you have to think about what's going on, because square root is not the only radical we have. As an example, this one here, which means the cube root, means that some number that I had is some number raised to the third power. What is the number? So for instance, if I had the number negative 8, I know that 2 to the third power equals 8. So this must be negative 2. Negative 2 times negative 2 is positive 4, but times negative 2 again is going to give me back to the negatives. So when I go to the third power, or the fifth power, or the seventh power, or the odd number powers, I'm allowed to have negative numbers. Okay? It's only when I'm going to the second power, or if I took a fourth root, I would have to have only positives because negative times negative makes a positive. Negative times negative makes a positive. So every time I have an even number of powers that I'm raising it to, I will have a positive answer. But if I have an odd number, remember I have negative, positive, negative, negative make a positive, and I have that one extra guy hanging out there that turns it back negative. So you have to think a little bit about your rules of exponents and about your rules of positive and negative integers when you're working these problems. Okay? Now, solving a radical equation is just like solving any other equation. So we have to get things out of their radicals. Step one is always going to be isolate the part that's inside the radical, or the root. Okay? Then square both sides. Now that's assuming that it's a square root. If it were a cube root, I would cube both sides. If it were a seventh root, I would take both sides to the seventh power. Okay? but we'll talk first about square roots to make sure we're comfortable. And then once you've gotten rid of the square root, you do all of your normal algebra steps and solve for x. So make sure you have those steps in your notes. And here's an example that you can also have to make sure you understand. So I have the equation 3 plus the square root of 6x plus 4 equals 7. Step 1, remember, is to get the root by itself. So I'm going to subtract 3 from both sides. And now I have the radical by itself and this other side. So now I'm prepared to square both sides. So I square this, and all it does is remove the radical. Boom, gone. I square this, and I get 4 squared, which is 16. Now I have a regular old pre-algebra equation that I can solve normally. I subtract 4 from both sides, and I get 6x equals 12. I divide both sides by 2 and get by 6 and get x equals 2. Okay? So think about the steps. I can't take the square of something until I've gotten that radical all by itself. Otherwise, I get a very messy equation that I have to FOIL, and you don't want to do that. Okay? The last thing we'll do is we'll just double check to make sure we get a legal answer. That is, when I put a 2 back in here for x, make sure that I get numbers that I'm allowed to have in the radical. So I do 6 times 2 is 12. 12 plus 4 is 16. The square root of 16 is 4. 3 plus 4, 7. So I got positive numbers inside here, so I'm safe. Okay? Now, sometimes you get, of course, this being Algebra 2, you get a quadratic when you go to do this, and you get some ookie-dookie numbers, in which case I can only suggest that you take a break, go get a candy bar, Powerade or something, and come back to it. Take a look here. I already have my radical by itself, so I'm ready now to square both sides. But when I square this side, I have to FOIL it. Okay? And I FOIL this out, and I get that. And I see right away I've got a quadratic. So when I have a quadratic, I'm going to get it in standard form by subtracting everything over to this side. So I subtracted 2x from both sides to get it 0 equals. And I see this, and it's not something that I can glance at and see that it's going to factor. So in it goes to the quadratic formula. And I worked it all the way out, plugged in my a, b, and c, worked, and I got a negative number inside my radical. That tells me I'm going to have an I, because that's what the I stands for, is the square root of -1. So I factored out that 28 to 4 times 7, because the 4 gets to come out as the square root of 4, which is 2. The negative sign comes out as an I, and the 7 stays inside. I had this number here, and I simplified because I noticed that every one of my terms has a 2. So I divided them all by 2, and I got -3 plus or minus I radical 7. This is an example of the complicated problems that you'll have to solve. Okay? So if you don't know how to do that, please copy that into your notes so you're able to do that. Now, let's talk about extraneous solutions. We've mentioned these before in other contexts, but essentially what an extraneous solution is an answer that you got correctly. You did all the math, you got the answer, it's correct, but it results in something illegal when we plugged it back in to check it. Okay? For instance, here's a sample. I say this, I see, oh look, I have my 2 radicals, they're by themselves, I squared both sides and now they're free of the radical. Let's see, I'm going to subtract that 4x from both sides, and I get 2 equals -2x, so I divided by -2, and I got -1 equals x. Great, that's my answer. Or is it? I went back and plugged in, whoops, it's kind of messy here, I plugged in a -1 for x, and I got -4 plus 2, -2, and 2 times -1, -2. Now it's true that the square root of -2 equals the square root of -2, that's true. Unfortunately, I'm not allowed to have a radical with a negative sign inside it, a square root. Okay? So this is an illegal in the real number system. Therefore, even though I got x equals -1, the answer to this would be that there is no real answer. Okay? There's only this imaginary answer, which will not work. Okay? So make sure you understand what an extraneous solution is and how you check to see if you have one. Oh, and that is our last slide. So bring your questions and we will work on this some more in class.